Writing mods for Subnautica can be difficult, but libraries such as Nautilus can make it easier. This video is about some common features of Nautilus, what they are and how to use them. I will assume you already know how to add references to your Visual Studio project. If you don't, please see this other video I made. To begin, let me clarify that I've added BepInEx and Nautilus as references to my project. You can find those files here and here. Let's start by requiring our user to have Nautilus installed. We can do that with this BepInEx attribute. BepIn dependency is an attribute that makes it so that the noted mod must be present, or else our mod will refuse to load, and the user will be notified. Nautilus.plugininfo.pluginGUID is a constant string value from the Nautilus mod. We use it to refer to Nautilus in terms BepInEx can understand. A common pattern for a mod is to allow the user to configure it somehow in the game. This is useful for custom keybinds, for example, or other choices that affect the way the mod works. Let's set up a config that has these options: a checkbox toggle, a numeric slider, and a custom keybind. I'll start by creating a new file. I'll right-click on my project name in the Solution Explorer and I'll click Add Class. For convenience, I'll add the following using statements: nautilus.options.attributes, nautilus.json, and Unity Engine. Let's change the name of the class to my first config, and let's have it inherit from config file. Config file comes from nautilus.json, and it allows this class to be interpreted as a list of configuration options. We additionally need a menu attribute, so I'll write that one line above the class name. The menu attribute is used by Nautilus to give our config options a section header in the options menu. The simplest configuration option is a checkbox toggle. By clicking this, the user can change a value between true and false. Here's how you write one. The Boolean value that will be changed is called isBoxChecked, but you can name it as you like. I want the starting value to be false, which will mean that the box is unchecked. Above the Boolean declaration is a toggle attribute. This attribute gives the config option a name and ensures that it appears as a checkbox in the menu. Another common configuration option is a numeric slider. This will allow the user to select a number between some minimum and maximum values. Here's how you write one. By declaring my number as a float, I allow it to take on decimal values. If I want them to be only whole numbers, I can change it to the int type. Everything else remains the same. The slider attribute has several parts. Of course, there is a name, and there are min and max values. Those are the required parts. But I've also declared a default value, which will appear in-game as a gray dot on the slider to indicate the normal configuration. There's also a step, which is how finally the user can configure a value. When the user slides the selection, the choice will increase or decrease by the step value. So if I want the user to be able to make a very precise choice, I might decrease the step to 0.1 or 0.01. The final common configuration option for today is a keybind. Some users play with keyboard and others with gamepad, for example, and want to have a choice for what button is important. Here's how you write a keybind option. The keycode enum comes from Unity Engine. All we have to do is name the keybind, but it can be less than obvious how to choose a default value. To see all possible keycodes, right-click the word keycode and choose Go to Definition. Most of the values are easy to identify, but I'll call out a few that are not so obvious. The alpha numbers are for the numbers above the letters on your keyboard. The keypad numbers are called keypad numbers. Mouse 0 is left click, and mouse 1 is right click. And there are 20 gamepad options across 9 possible gamepads. Now you have all the common examples, but I'd like to show a less common example. Sometimes you want to offer the user a limited number of choices that have names. In this case, you can use the choice attribute like this. The choice attribute has a name, as always, and it has an options part. The options part is an array of strings. In this example, I declared the array of strings in line and filled it with these values. Now the user can pick between these options. Okay, now that we've written our config options, let's register the menu with Nautilus. To do so, we'll take a few steps. In main patcher, I'll declare a new member called myConfig, and it will be of the type of our new config menu. I've declared the config menu as a property, which allows me to control who can get and set it. By making the setter private, I can protect it from being overwritten somewhere else. Now, in mainpatcher.start, I'll register the menu and save it to my new member, like this. Now I can access the currently configured values from anywhere, like this. Let's check in-game to verify that our options menu is appearing and working correctly. After booting the game, I'll go to Options, Mods, and scroll down to our menu. There it is, and everything looks okay. Okay, that's it for the first part of this video. Now let's talk about save data. Sometimes you want data to persist even when the user closes the game. That way, your mod can remember that data when the player next opens up the game. It's important to note that configuration values are already saved by Nautilus, so saving data in the way I'm about to describe is a relatively exotic use case. This feature differs from config values because config values are Subnautica wide, but this save cache is actually only worldwide. So if the player has several active save files, for example a creative game and a survival game, our mod will cause 2 different save caches to be created by Nautilus. This process is similar to making a config menu, so let's dive right in. I'll start by making a new file and creating a class that inherits from save data cache. For convenience, I'll write these using statements. This class needs a file name attribute, which will be used by Nautilus to name the resulting file. This file will be stored on the user's computer, and Nautilus will find it later to allow our mod to remember what was saved. To make it easy, I'm only going to add 2 fields to the save data, both of which are strings. That's it for this file. Now in main patcher, I'll declare a new member like before, this time of type save data. And in mainpatcher.start, I'll write the following. This line registers our save data with Nautilus, so that Nautilus knows to save our data and to check for saved data in the way we will describe. This block saves our data to file. This block will retrieve our saved data from the file and load it into the My Saved Data member we created. Now I can access the saved values from anywhere, like this. Okay, now we know about using Nautilus to create configurable options and save persistent data. These are powerful features that you can use to create mods that are more customizable, have persistence, and are altogether more interesting. I hope you feel empowered to use Nautilus to create cool mods. If you have any questions or ideas for future videos, let me know. Until next time, happy modding.